Hello, my name is Brant Bullister and I'm the Mechanical Design Engineer at Cross Motion Solutions. In today's video I want to show you where you can find CAD files to put inside of your workspaces, as well as how to make them so that they will be the easiest to use inside those workspaces. So to begin, we're going to go to www.universal-robots.com. That will bring you to this page. From there we're going to go to Support. From there we're going to go to Download. In the drop-down box, we're going to select Mechanical Documentation. From there, we're going to select which robot we want to work with. In this case, we're going to pick the UR5. From there, we're going to pick Robot CAD File. And now we're given a step file that we can download. So now you'll want to unzip the file that you downloaded and open that step file in your CAD program. I'll be using Autodesk Inventor, but the principles that I'm going to discuss will work in any CAD program, and there's an equivalent to whatever I will be doing in here and whatever you're using. For now, we're just going to do one joint in this video to keep it short, and you'll repeat this for each joint. Not all might have the axes in the right place. For this, you're just going to have to go in and use your design knowledge to go in and fix your own axes. If you are needing help with this, I can contact me further and I'll be glad to help. So the first thing you're going to want to do is make sure that your base plate is what is grounded or fixed in your model, and that should be the only grounded or fixed item. If there's another item, sometimes this comes through with another joint grounded or fixed. You're going to want to unground or fix that and make sure that this base plate is fixed. So in order to control this, we're going to start. We're going to constrain the x-axis of the first joint to the center axis of the base plate. We're going to apply. Next, we're going to constrain the bottom of the joint to the top of the base plate. We're going to apply. Now right now, this joint is allowed to move freely. Some people will let this happen and leave this way and leave it as a not being a fully constrained model. We're going to want to avoid this because with 6 degrees of freedom, if you're just grabbing the head of this robot trying to move it where you want, it's going to go. It's going to look like it's flailing and not go where you want to go. In order to get these precise movements that you want, we're going to need to fully constrain these and then control each degree of freedom through a different variable. To do so, we're going to select one of the planes that is perpendicular to the base plate when in our constrain mode. We'll choose the XZ plane. Next, we're going to pick one of the base planes that are perpendicular to its flat plane. And we're going to go to one of our angle constraints. Now we can actually control what degree we want this at. 180 degrees puts it back in its original position. I have 90, whichever you want to do. Get out of our constraints. We're going to rename this Axis 1. And what you're going to want to do is repeat this throughout the robot, and you'll end up with 6 axes, each controlling a different joint. After you've done this to each of the joints, you'll go to your parameters or global variables or whatever your CAD program uses, and use this section to control your robot. In Inventor, you'll need to rename your parameter names to match your axes. For example, when you highlight over this one, axis 6 is consumed by axis 6. The first name is the parameter name, and the second is the name that you gave inside the model tree. So you'll need to go. I've already renamed these, so you'll need to go back and rename these. But now that you've done this, you can go and control your different axes through here. Let's make this 80. Robot turn some. Let's see. I want to lean over a little bit more. Move up some. With this method, you will be able to finely tune and control your robot and get the specific degree you want rather than just letting it wildly flail while you grab one part and move it. That is all for today. If you have any questions, feel free to email me at brant.bullister@crosscode.com or visit our site and you can get in touch with me through there. Thank you and have a good day.